Hello, and welcome to Tech presented by Kaizen, where we will explore common cleaning questions and answers. This session has been pre-recorded and will include additional FAQs related to this specific topic at the end of the presentation. We hope it is 15 minutes well spent. Let's get started. I would like to introduce Kaizen's own Ethan Mueller.
Thank you, William. Good morning and welcome to another episode of Tech to Tech brought to you by Kaizen, where we share some technical insight on cleaning and corrosion preventative processes and things like that. Our topic today, summertime corrosion, yellow metals, and how we how we prevent corrosion on our yellow metals. We're trying to beat the heat. So when we're talking about yellow metals, we're not talking about gold. We're talking about brass, we're talking about bronze, and copper fits into that as well. The presentation that we're going to be going over today is going to be mostly focused on brass, um, but bronze is kind of involved in that as well, and copper is going to fit into it in some regards as well. So the composition of our yellow metals, brass specifically, brass is composed of copper and zinc, and bronze is composed of copper, tin, and then it has some other trace elements. So we have a wide range of bronze alloys. There's a lot of various brass alloys as well, but that's more of a variance in the amount of copper to zinc ratio. So when we're talking about our yellow metals, sometimes they undergo oxidation, and sometimes these oxidation processes are considered favorable. And maybe you've heard of patina. And what's happening with when a yellow metal forms a patina, what's happening is you're creating an oxide layer, a metal oxide layer at the surface of that part. And that oxide layer is not active. And so it's actually protecting the base metal below. And so the oxidation doesn't progress from there. It actually forms a corrosion resistant oxide layer. Um, an unfavorable example of oxidation is this is specifically looking at brass is what's known as dezincification. And what's happening here is the zinc component of brass is corroding away. It's preferentially corroding and coming away from the part and just leaving that copper structure behind, which can impact our the rigidity of the part and the hardness of the part and lead to failures and stuff like that, things that we don't want to see with our metal parts. Um, Patinas, they can be favorable in a sense, but it can also be unfavorable, especially in the manufacturing world where we're going to go and plate or paint our parts. The patina leaves our surface inactive or not active, and so when we have that, it a finishing won't take to it, a plate won't take to it. So we want to keep our surface active. We want to prevent that patina from occurring. And in this case, a patina would be an unfavorable oxidation. So, maybe you're dealing with a situation where your parts are already oxidized, and that's not unlikely. People deal with that every day. It's there's multiple different ways you can go about it. One of the very common ways is doing a chemical etch. Very typically, acids are used to etch away the oxide layer to expose that base metal. And so you can go ahead and do your plating process or your painting process or whatever it is you're going to do. When you're looking to do a chemical etch, it's good to look at some engineered fluids as opposed to commodity, just raw commodity type things. Um, these are what I'm going to call more surgical. They're designed to not go after the base metal, and so you're more focused at removing that oxide layer as opposed to going in and impacting your base metal. The engineered fluids, if the exposure time is too long, you probably will start to go after your base metal, so you do want to be careful with that. But it's got, these fluids are developed for this exact process, and they tend to have more of a soft touch, or again, they're more surgical, if you will. When we are looking to etch our parts, we want to avoid amines when we're dealing with brass and bronze if it has zinc in it. Amines extract the they extract the zinc from the surface of the part, and that's actually causing dezincification of your yellow metals. And so we want to avoid amines at all costs. And a lot of products out there, a lot of cleaning products and stuff have these functional groups in them. So just be aware of that. So to make when we are machining our parts and we're looking at, we need to maintain that surface. We need to keep our surface active so that we can do our downstream processes um, unimpacted. There's a couple of different ways that you want to go about doing this. You want to keep your parts wet. So typically when we're turning our parts on a lathe or a Swiss machine or something like this, there's cutting oils there, and those cutting oils are going to help us. They're going to provide a barrier to the atmosphere, and it's going to help protect our part. But typically, these fluids aren't designed for long-term protection or any corrosion protection at all. And so, we want to do a follow-up step, but this is a good interim to get from your Swiss part to the washing process and then to the shelf. uh, Sometimes these cutting fluids are hydroscopic, which means they allow water to come in, and that can cause corrosion. So again, these fluids they're really not designed for corrosion protection, but we can kind of rely on them to get from our cutting machine to the wash process, which is where we're going to apply our corrosion inhibitors. And there's a few different uh, types of corrosion inhibitors. There's dry film, which is more of uh, it's more of a dry to the touch type of thing. You can feel it. It's maybe a little waxy, um, but it's dry, if you will. And then there's wet coatings, which is more of an oily feel, and these are more for long-term storage conditions or maybe oversea transit, and those are gonna give your parts an oily feel or a wet feel. And then kind of building on that wax coating, that fits somewhere in between there. That is that waxy, tacky type feeling, and that's just gonna coat your parts in a wax-like material, and um, it's gonna provide a barrier from the atmosphere. So when we're looking at our parts, we there's a few things we need to take into consideration when we're looking for the right inhibitors to choose. We need to consider our transit and our storage conditions. Um, if we have harsh transit conditions or we're sitting on a shelf in a very humid climate, we might want to go for one of those wet type of corrosion inhibitors, something that provides more of a long-term protection or a more robust protection. If we're in a climate controlled environment, the dry film is probably perfectly all right. But these are some things that we need to look at when we're trying to select the corrosion protection that we want. How long do the parts need protection? So that kind of wraps back up into that. How long are your parts going to be sitting on a shelf? What is the climate of that storage going to be? And then the downstream processing. Are we going to paint or plate these parts? And if so, is there going to be a pre-clean prior to that painting or that plating step? Or is there an acid etch step? These things typically these inhibitors can be removed pretty easily in some sort of pre-cleaning application, which you certainly need if you're going into plating. Um, and a lot of times the plating line will have that right in there. It'll be some sort of dip process, and it'll go through a cleaning stage before it goes to the actual plating tank. And so that and that and that in that dip process, you'll be removing that coating so that you can get a nice plate. And painting, it depends on the material. Sometimes you can paint right over it, but it's pretty likely you might want to remove that to get a good adhesion between your metal and your paint. And an acid etch step would allow you to potentially forego an RP or a corrosion inhibitor, and it would allow you to maybe just etch your part right in the plating process. So our storage and transit conditions, there's a few things we want to avoid and try to pull these levers to control kind of the conditions that our parts are subjected to. We want to avoid high humidity environments. We certainly want to avoid direct contact with water. However, sometimes we can't control these things, and that's why we look at corrosion inhibitors, and we kind of circle back to some of those things that we just previously discussed to kind of look at what that corrosion inhibitor might look like, what kind of material that might be. So once we apply the inhibitor, we want to ensure that our parts stay protected. So of course we start by applying the right inhibitor at the right concentration, so on and so forth. But from there, we want to make sure that we package our parts accordingly. Um, a lot of times what you'll see people take parts right off the line, and they'll put them directly into a plastic bag, and they'll seal it up and put it on the shelf good to go. And kind of the problem that you're having there is there's a good possibility that there's moisture on those parts, and the parts are hot, and so it's kind of like a humid environment trapped in a bag, and that humid moisture comes off and it condenses in the bag, and you get oxidation. Um, so we wanna take the right steps to package our parts properly. VCI bags are certainly something that can help. Those are the corrosion preventative bags. Desiccants can be useful if we're in a humid environment. And again, a climate controlled warehouse is definitely a good scenario for our parts to be stored in, but it's not necessary, and that's where we're going back to that inhibitor to do what we can to protect our parts when we can't control the climate. Um, and one thing that's worth mentioning is these corrosion inhibitors aren't meant to be they're not meant to be permanent protection. They're more for a few weeks to a few months to maybe upwards of a year. But to really get the permanent protection that you need on these parts when they're out in the field, we need to either paint or plate our yellow metals to get that permanent protection that is probably desired. All right, so some frequently asked questions that we get on the topic: will an acid etch brighten my parts? Yeah, it will remove that dull oxide layer. However, it might give you an uneven or somewhat of a spotty look. Um, Typically, it's not used for per se brightening parts, but it does remove that oxide layer. It does kind of shine them up a little bit, but it might not be the look you're looking for. It might not be the appearance you're looking for. In which case, you might want to look at some sort of chemical brightening or electro brightening um, process. Are there any environmentally slash operator friendly choices for an acid etch? Yes, citric acid tends to be a very good etching etching acid. It works really good for not only brass and bronze and copper. It also works on aluminum and maybe even light oxide on steel parts. And this is it's acidic, but it's about a pH of a 3, which is relatively compared to some of the other acids out there which have pH of 1. It's a little bit more friendly than that, and it's derived from citric fruit, lemons, oranges, things like that, and so it's typically considered to be environmentally and operator friendly. Do I need a standalone corrosion inhibitor piece of equipment? No, generally, this is built right into your wash process. So when you go from your cutting tool to, the washer, typically these inhibitors are going to either be built into the the soap or the chemical that you're using to clean the parts, or you can add a standalone corrosion inhibitor to the rinse on your wash process. And so you don't need a standalone piece of equipment. They're out there. You could do it. It would probably look just like a dip tank or something like this with the corrosion inhibitor in there. And then you dip your parts in, take them out, let them dry, and the water dries away, and the inhibitor is left behind. But typically, this is built right into the wash process. Can I plate directly over corrosion inhibitors? I would say that when you're plating your parts, you want them to be as clean as possible. And fortunately, typically a plating line will have a pre-cleaning step in it where it's going through a series of dip tanks and there will be some sort of cleaning stage in there. And so that should be enough to remove the corrosion inhibitors. Um, but no, you cannot plate directly over corrosion inhibitors. You would want to remove them and you would want your surface as clean as possible to get as even of a plate as possible. And with that, I'll turn it back over to William.
Thanks, Ethan. Thank you all for watching this Tech to Tech session. If you'd like to discuss this topic further or have any questions not answered in this session, please contact your local Kaizen regional manager or send an email to tech at kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox? Or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech by kaizen.com, fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.